Good morning, students. This is Ramya Harka. I'm going to discuss about the analog and digital electronic circuits laboratory. Due to this pandemic situation, we couldn't complete the complete lab experiments in our lab. So now we are going to explain all these experiments through virtual mode, that is through online. So actually the lab name is complete lab name is Analog and Digital Electronic Circuits Laboratory. So totally 12 experiments will have to conduct in this laboratory. 6 experiments from analog electronic circuits and 6 experiments from digital electronic circuits. So analog electronic circuits experiments will be conducted by Swami sir and Venkateswara sir. And digital electronic circuits experiments will be conducted by myself, Hari Prasad sir and Rakesh sir. Now just I want to recollect all the experiments once again which are present in the digital electronic circuits laboratory. So first we'll recollect the experiments. First one is realization of logic gates using discrete components. We are all familiar with the logic gates: AND gate, OR gate, NOT gate, XOR, XNOR, NAND, NOR, here all of them. And discrete components like diodes, resistors and transistors. So by using this we need to construct our logic gates. So this is our first experiment. And the second experiment is realization of logic gates using universal logic gates. So in all the logic gates, the universal logic gates are NAND and NOR. So by using NAND and NOR logics, we are going to construct AND gate, OR gate, NOT gate, XOR, XNOR. Like that, we have to do the second experiment. Third experiment is realization of adder and subtractor using universal logic gates. So if we observe second, third and fourth experiments by using universal logic gates, means by using a NAND and NOR logics, you need to construct the logic gates and the combination circuits and the sequential circuits. So here the combination circuits are adders and subtractors. So what is the difference between combination circuits and the sequential circuits is, in the combination circuits the output will depend only on the present inputs. But coming to the sequential circuits, the output depends upon the inputs, present inputs and the past outputs also. So memory element is present in the sequential circuits. So we have a different type of adders, but here we discuss about only basic adders: half adder, full adder and half subtractor and full subtractor. Just we need to construct the circuit, and then according to the truth table we need to check the output. And fourth experiment is realization of flip-flops using universal logic gates. So flip-flop means this is also one kind of sequential circuits, and in the flip-flop we store only one bit of data, and we have varieties of flip-flops: JK flip-flop, D flip-flop, SR flip-flop, T flip-flop and master slave flip-flop. Like that, so many different types of flip-flops are present. We need to check all the flip-flops here: SR flip-flop, D flip-flop, JK flip-flop, T flip-flop, master flip-flop, by using NAND or NOR logics. We need to check our truth tables. Next, realization of counters. Here also we know counters is also a kind of sequential circuit. It is example of sequential circuits. Here also we have different type of counters: synchronous counters, asynchronous counters, like that. Here we discuss about the up counter and the down counter. Means up counter means adding of the means counting the numbers from 0 to n, and in the down counter we will be decrementing the count. Next, realization of shift registers. Shift registers means shift registers is also the sequential circuit. So if you observe flip-flops, counters, shift registers, these are all the examples of the synchronous circuits. So in the shift registers we are going to store the information, and also as well as storing the information, and also shifting the bits bit by bit. Shifting the bits bit by bit, we can shift right or left. So here we can observe right shifting and also left shifting. So for these counters and shift registers also, we need to have the basic flip-flops. So by cascading the flip-flops, we can perform the experiments of counters and shift registers. So the detailed explanation of this each and every experiment will be explained in the next sessions. First, I'll give the overview. Means actually I have discussed the experiments, but for this we need to know some basic things to do these experiments. So we'll discuss first those things. So for performing our digital electronic circuits laboratory, we have some kits. So in that kits, we can directly give the connections, inputs and outputs, and then we can check the truth tables accordingly. So for that, we need to know some ICs. Now what are these ICs means? Each and every logic gate is embedded in an integrated circuit. Clear? So for example, we'll see one gate, NAND gates. To construct the 2-input NAND gates, we are going to use IC7400. The IC will look like this, and in that IC we have 14 pins. In that, how many pins we have? 14 pins. In that 14 pins, the 14th pin is applied to the VCC, that is power supply, and 7th pin we are going to ground it. And the remaining 12 pins are used for the 4 NAND gates. How many inputs and how many outputs for each and every NAND gate is? For example, if we consider 2-input NAND gate, 2 inputs we have, 1 output we have. So how many pins we have to have for that 3? Means for that NAND gate, 2-input NAND gate, only 3, right? 1 and 2 are the inputs, A and B. For example, if we consider A, B are inputs, Y is the output. So how many pins we have? 3. So for constructing 2-input NAND gate, we have 3 pins. Like that, if you want to construct 4 2-input NAND gates, 4 into 3, 12 pins we require. So if you see here, in 14, if you minus 2, how many pins we have? 12 pins we have. So in the 12 pins, we can construct 4 2-input NAND gates. So see here, this is the first NAND gate. 1, we have the symbol 1, right? This is the first NAND gate. In that input gates, if A and B are the inputs, then this is A, this is B, this is Y output. Like that, this is one NAND gate. Like that, similarly 4, 5. These are the input, 6 is the output. This is one another NAND gate, and this is one another NAND gate, this is one another NAND gate. Like that, we can construct 4 2-input NAND gates by using one single IC. Then different ICs are there for different logic gates. 7400 is the NAND gate IC, 7402 is the NOR logic gate, 7404 is the NOT logic gate, 7408 is the AND logic gate. Like that, for each and everything we have ICs, different ICs. So this thing you need to learn first. For XOR also we have gates. XNOR also we have gates. Like similarly for each and everything. See here, this is the 3-input NAND gate. Okay, means see here inputs are there, here output is there. Means we need to give 3 inputs. In the previous thing you have only 2-input NAND gates. Here we have 3-input NAND gates. Means we have to give 3 inputs and we will get 1 output. Like that. Here you can take any number of inputs, right? So for example, if we take 3 input NAND gate, it will look like this. The IC number is 7473, like that you have to take. Okay. Now first I will show how our kit will look like. Okay. In our lab I said that we have kits to perform these experiments, 6 experiments. So our kit will look like this. See here, for each and every experiment we need to give the inputs. For example, come to the half adder experiment. Half adder experiments we have AB input, sum and carry are the outputs, right? So we want to give the inputs A and B as 0, 0, 0, 1, 1, 0, 1, 1 like that. How will you have to take so many inputs are there right here. So you can consider any 2 inputs as A and B. You can change 0 to 0 to 1 or 1 to 0 like that. 4 combinations you have if you take 2 inputs like that. These are the inputs. And finally, what are the outputs of the half adder? Sum and the carry are the half adders. So that outputs you need to give to this output indicator. So these are the LEDs. These are the switches. Inputs usually we have the switches. Outputs we have the LEDs. Outputs you have the LEDs. Inputs you have the switches. Clear? Now I have said that we have all ICs. In this kit you have all the ICs. I have previously said that 2 input AND gates will be using 1 IC. 2 input OR gates will be using by 1 IC. 2 input NAND gates will be 1 IC like that. So total number of gates will be 4. 4 2 input AND gates, 4 2 input OR gates, 4 2 input NAND gates, like that it will be there. Okay. The input we have to give from this to here like this. Okay, if you want to check one AND gate input, so 2 inputs to this AND gate, A, B will give 0, 0. We'll check the output from this third input, third output, third pin, and this third pin will be placing a wire from third to output. You can take any output. Here you have 10 or 11 outputs. In that you can take one output and set to the output here. Clear? So if you give 1 1 here for the AND gate, you will be having 1, means the LED will be glowing in the output indicator. Clear? Like that you have to give connections for each and every circuit. So for conducting of first experiment, second experiment, third experiment, fourth means logic gates, realization of logic gates, realization of full adders, half adders, realization of flip-flops. So first see here, for realization of flip-flops you need to have for example, if you observe JK flip-flop, you need to give 3 input NAND gates. You need to give 3 input NAND gates, right? So for that you need to take this 4 input NAND gates. You need to take 4 input NAND gates. Okay. Then again next one is realization of flip-flops. So for the flip-flops I have said, for JK flip-flop you can do, remaining for that you can take 2 input NAND gates. You can take 2 input NAND gates. And then after that, for realization of shift register, you have the shift register directly IC for 4 bit. See here, for 4 bit right and left shift register we have an IC 7495. IC 7495 is used for 4 bit shift register. And for realization of counters you have here this one. For realization of counters you have this IC 7476. So for each and every experiment you have the kit here only, you have the pins here only, just you need to give the input from this and you need to check the output in the output indicators. Clear everyone? Okay, so from the next session we'll give detailed explanation for each and every lab. Okay, thank you.